friends, welcome you to my YouTube channel Make Mathematics Easy with Manoj Bahuna. In this video, we will learn to solve question number 3, 4 and 5, class 10th Mathematics, chapter 9, some applications of trigonometry. Question number 3 is, a contractor plans to install 2 slides for the children to play in a park. For the children below the age of 5 years, C prefers to have a slide whose top is at a height of 1.5 meter and is inclined at an angle of 30 degree to the ground. Whereas for elder children, C wants to have a steep slide at a height of 3 meter and inclined at an angle of 60 degree to the ground. What should be the length of the slide in each case? To solve the question, for the children below the age of 5 years, let AC is the slide. Here we can see that AC is the slide whose top A is at a height of 1.5 meter. Here AB is 1.5 meter from the ground. Point B is on the ground and the top A of the slide is at a height of 1.5 meter from the point B. The slide is inclined at an angle of 30 degree to the ground. Here we can see that ACB is 30 degree. So angle of elevation from the point C to the top of the slide is 30 degree. So as we given that AB is equal to 1.5 meter and angle ACB is equal to 30 degree. Now in triangle ABC, here ABC is a right angle triangle in which AB is the perpendicular of the triangle, angle ACB is 30 degree and the slide AC is in the form of hypotenuse of the right angle triangle. So we have to find out the length of the slide, which is the hypotenuse of the right angle triangle, and AB is the perpendicular. So ratio of perpendicular to the hypotenuse means perpendicular by hypotenuse is the trigonometrical ratio sine, and angle of elevation is 30 degree. So sine 30 degree is equal to AB divided by AC, and we know that AB is 1.5 meter. Length of AC we have to find out, and the value of sine 30 degree is equal to 1 by 2. So 1.5 divided by AC is equal to 1 by 2, and by solving it after cross multiplication, AC into 1 is equal to AC, and 2 multiplied by 1.5, and after multiplying 2 and 1.5, AC is equal to 3 meter. So the length of the slide for the children below the age of 5 years is equal to 3 meter. Now for the children above the age of 5 years, and in this case let PQ is the slide, and this time the top P of the slide is at a height of 3 meter. Here PR is equal to 3 meter. So the top is at a height of 3 meter from the ground. Point R is on the ground, and the slide is inclined at an angle of 60 degree to the ground this time. So PQ is the slide, RQ is the ground level, and angle of elevation from point Q to the point P is 60 degree. So PR is equal to 3 meter and the angle PQR is equal to 60 degree. So in triangle PQR is again a right angle triangle. Again we have to find out the length of the slide PQ, which is in the form of hypotenuse. PQ is hypotenuse, PR is perpendicular, so the trigonometrical ratio will again be sine 60 degree because angle of elevation is equal to 60 degree. So sine 60 degree is equal to PR by PQ, and by substituting the value of PR, which is 3, PQ we have to find out, and sine 60 degree is equal to root 3 by 2. Again by cross multiplication, root 3 will multiply to PQ, root 3 PQ, and 3 into 2. 3 multiplied by 2 is equal to 6, and root 3, which is in multiplication with PQ, when will transfer to right hand side, it will go to the denominator. So PQ is equal to 6 by root 3. Now rationalizing the denominator or multiplying numerator and denominator by root 3. So 6 multiplied by root 3 and root 3 multiplied by root 3. In numerator we will get 6 root 3, and in denominator root 3 into root 3, root 9. Root 9 is equal to 3. So PQ is equal to 6 root 3 by 3, and 3 will divide 6 2 times. So PQ is equal to 2 root 3, and this is the length of the slide for the children above the age of 5 years. Hence, length of the slide for the children below the age of 5 years is equal to 3 meter, and for the children above the age of 5 years is equal to 2 root 3 meter, and this is the answer of the question. Next question is, the angle of elevation of the top of a tower from a point on the ground which is 30 meter away from the foot of the tower is 30 degree. Find the height of the tower. To solve the question, we again let AB is a tower. Here AB is a tower. The foot point of tower AB is B, and from B a point C, we can see here the point C is 30 meter away from the point B, and the angle of elevation from the point C to top of the tower A is equal to 30 degree. So in triangle ABC, AB by BC, AB perpendicular and BC base. So ratio between perpendicular and base is also equal to 10. So AB by BC is equal to 10 30 degree. And now substituting the value of BC, because AB is unknown, BC is equal to 30. So AB divided by BC is equal to 1 by root 3, because the value of 10 30 is equal to 1 by root 3. Again by cross multiplication, AB is equal to 30 will multiply to 1. So 30 and root 3 is already in denominator. So AB is equal to 30 by root 3. Again, for rationalizing the denominator, multiplying numerator and denominator by root 3. So AB is equal to 30 root 3 divided by root 3 into root 3. This will give 30 root 3 by 3, and 3 will divide 30 10 times. So we will find the value of AB is equal to 10 root 3. Hence the height of the tower AB is equal to 10 root 3 meter. This is the answer of the question. Next question is, a kite is flying at a height of 60 meter above the ground. The string attached to the kite is temporarily tied to a point on the ground. The inclination of the string with the ground is 60 degree. Find the length of the string assuming that there is no slack in the string. To solve the question, we assume that let PR is a string attached to a kite. We can see here a kite is attached to the string PR at its upper end P, and the lower end of the string is temporarily tied to a point R on the ground. You can see a point R is blinking here. So the lower end of the string is temporarily tied to the point R. Kite is flying at a height of 60 meter above from the ground. So PQ, Q is point on the ground, and PQ is equal to 60 meter, and the inclination of the string PR with the ground is 60 degree. So angle of elevation is 60 degree from point R to the upper end of the string. Now PQ is 60 meter and angle PR Q is equal to 60 degree. So in triangle PQR, PQ is perpendicular and PR is hypotenuse. So again, ratio between perpendicular and hypotenuse is equal to sine 60 degree is equal to PQ by PR. And substituting the value of PQ and sine 60 degree, PQ is equal to 60 meter. So 60 meter divided by PR is equal to root 3 by 2, which is the value of sine 60 degree. And after cross multiplication, PR root 3 is equal to 60 into 2. 60 into 2 is equal to 120, and root 3 is in multiplication with PR, and when it will come to the right hand side, it will go to the divide. So PR is equal to 120 by root 3. Now again, multiplying the numerator and denominator by root 3, or rationalizing the denominator of 120 by root 3, we will multiply by root 3 to numerator and denominator. So PR is equal to 120 into root 3 by root 3 into root 3, and 120 into root 3 will come in the numerator, and root 3 into root 3 root 9, and root 9 is equal to 3 will be the denominator. And now 3 will divide 120 40 times. So PR is equal to 40 root 3, and this will be the length of the string. Hence the length of the string is equal to 40 root 3 meter. This is the answer of the question. If you like the video, please like and share the link of this video, and subscribe the channel Make Mathematics Easy with Manoj Bhogana, so that you can get the notification of every new video. Thank you.